This is an illustration of a screening tool for detecting and documenting exceptional air quality events that cause the violation of the National Ambient Air Quality Standard. In order for a violation of the standard to be flagged as exceptional, it must meet a series of criteria and steps specified by the exceptional event rule. There are several criteria that an event must meet in order to be qualified as exceptional. These include that the event must not be reasonably controllable, that there is a clear and causal relationship between the exceedance and the event, that the event has actually increased the concentration of PM 2.5 or ozone, and that the violation would have not occurred but for the event. The following is an example of how the DataFed browser and the decision support system can be used to gather evidence for each of these criteria. Displayed in this first layer is the location of ozone concentrations exceeding 75 parts per billion on a given day. On April 12, 2011, we can see that there are ozone exceedances in eastern Kansas. We can select the FirePixel layer and make it visible, displaying it on the map view. The next layer displayed is the FirePixel layer, which gathers NASA satellite data and shows that there are high levels of fire radiation. Again, there is an accumulation of fire radiation in the eastern Kansas region. This image layer from the NASA Aqua satellite shows the smoke originating from the Kansas fires. If we zoom in on the fire region, we can see the presence of smoke in the vicinity of the stations that measured concentrations above the ambient air quality standard. The fires represent the exceptional source over the eastern Kansas region. The causal relationship between the exceedance and the fires is shown by the back trajectories. We see here that the airflow passes through the fire zone prior to arriving at the eastern Kansas stations. Additionally, this layer shows data taken by a NASA satellite, which detects the column concentration of nitrogen dioxide, a precursor to the formation of ozone. Here we can see that the nitrogen dioxide is highly concentrated over the fire region. The most compelling evidence is contributed by the Navy Aerosol Analysis and Prediction System. This air quality model assimilates the satellite-detected fire locations and smoke optical thickness to predict the three-dimensional smoke concentration downwind from the fires. The highest concentrations of predicted smoke are found in the area of where the Kansas fires were located. The evidence that the measured ozone is well above the normal levels is shown in the ozone anomaly map and time chart. At the monitoring site, the 3-year median ozone concentration is 52 parts per billion. The exceptional sample shows 84 parts per billion, that is, an excess of 32 parts per billion over the normal values. After the evidence has been gathered, the states can flag an event to be reviewed via the following process. Analysts at the state level can examine events, trends, and concentrations and send the data with justification to the regional EPA. The flag, upon approval at the regional level, is then sent to the federal EPA, who can decide whether the event can be classified as exceptional. The decision support system is a tool that supports every level of this process, from identifying candidate events to the eventual determination of the exceptional nature of the event.